Ooh, it lied again. Good afternoon, GitOpsians. Sorry that we're starting a couple minutes late. We had actually, we didn't have technical difficulties. I'm just a chatterbox, and that's really what happened there. I'm not even going to lie. Quick couple of announcements again before I introduce our guests. So this one's big. This one's very big. I'm extremely excited to announce the return of Christian Hernandez to the GitOps Guide to the Galaxy stream. He will be rejoining us back next month after. So he's at KubeCon North America in Detroit right now, specifically for or about to be rather, specifically for GitOpsCon and of course the greater convention at large. So after he's, done with traveling, he has returned to us here at Red Hat after a brief time in the great unknown. And so yeah, we're very, very excited. I'm very excited to announce that he's going to be rejoining the stream as my co-host later next month. On that exact same thing, we're going to be figuring out the rest of our show schedule. I had something set somewhat in stone. Obviously, with his return, that becomes more flexible. I believe our next stream is still going to be Argo rollouts on November 7th. And then actually later in November, I will be away on vacation. So I don't think we're going to have a second stream in November. And then we'll get back to you all first week of December / top of the new year with everything that we're planning to do going forward. The dynamic duo is going to be back together. I'm extremely excited. So that said, it's my turn to badly introduce, as per usual, today's stream guest. Cesar, I didn't actually practice saying your last name ahead of time. It's Quintana?
Yeah, Quintana. Yep.
Quintana. Cesar Quintana. I'm not going to even try to explain your job. I'm going to let you just take it from here.
Yeah, absolutely. No, thanks, Hilliary. So so my name is Cesar Quintana. I am a principal solutions architect at OpsCruise. Basically, sales engineer, right? So my job is to interface with customers and make sure that we get them properly set up on our awesome observability platform, OpsCruise. And I've been in the IT space for quite a long time, maybe I guess 16 years at this point, something like that. And in the observability space for probably about the last 9 or 10. I come from a background of a lot of APM platforms, major APM platforms. You think of them. Yep. Those are the ones. So it's awesome to be here, and I'm very happy that I get to join you, Hilliary.
So, let's just go ahead and ask the stupid question. APM, that's one of our least favorite, most favorite things, a 3-letter acronym, or TLA. Can you expand your acronym?
Absolutely. So APM, application performance monitoring, right, or application performance management. I think it's gone through a few different iterations, but I think at the core of it, APM really refers to code tracing, right? The distributed, what's now known as distributed tracing, the instrumentation of code libraries in order to track and identify requests, basically conversations, the flows of your business operations. Some platforms call them business transactions. We call them trace paths. The point is, those are business critical, operations in your application. And the whole APM construct is built around instrumenting those pieces of code and really following a request or a transaction from the beginning of its life cycle all the way through the end, and understanding the performance, especially now with microservices, right? It's super, super key. Before it used to be just one giant monolith and everything was internal to it. But now with the increase in distribution of the services, the whole microservice paradigm, being able to track at each hop what pieces of code are being run, what functions are being run, and being able to trace their performance as well as any problems in their run is super key. So
yeah, absolutely, 100%. Yeah, distributed tracing is a big topic. It comes up, right? I'm a reliability engineer. Comes up almost every single day, I guess. It's one of those things where, especially during an incident where it's not immediately clear what's going on, right? And, back when you talk about monoliths, right? How many times I went to look at SSL access logs to kind of figure out where the connections were coming from that might be, part of an issue. I can't count. And in today's services, that's not really the same way anymore, right? You don't necessarily have that one ingress point exactly in the same way that tells all, because there's a lot of little bits that all talk to each other in different ways. And I know that you know this, and I know this. This is not my first time seeing OpsCruise, and my favorite thing was the network tracing visualization that you had in there. So, like, if you weren't planning to show that, I hope you do now, because that's my favorite part.
Yeah.
But I do know that you have some stuff to show to the audience, a live demo to go through.
Yeah.
You sent some links to us earlier. As we let you go through this, we'll kind of put them in the chat for people to take a look. And I'll just let you, let's just jump into it, get started. Go ahead, share. Well, you'll have to, I should have told you this before we started. You'll have to share your screen, and then I'll enable your screen, and then it will come up beautifully. So
That's fair enough.
If there's a delay in the share, it's just it's waiting on Johnny or I to run the production aspect of that.
All right, that sounds good. So while I share, let me actually move you guys so I can still see your guys' face when you talk to me. But
you don't need to look at my face. That's unimportant. No, it's terrible, right? I have this giant, it's a 49-inch monitor. It's mounted on the wall in front of my desk, right? And my camera sits on top of it. It's right here. This is where you guys are, right there. So if I'm looking here, it's great. You've got me dead on, right? But if I have anything else, right? I'm over here. You guys are getting the side of my face. And that happens. I just in 2D world that we live in with these remote streams and so forth, I think we have to just get kind of used to looking at the side of each other every now and again.
Yeah, it looks like you're distracted watching, you're watching something else, right? When you're at reality, just paying a lot of attention.
Yeah, exactly.
So hopefully you guys can see my screen here.
If you can make it, I don't know why I pantomime this. Like, this is helpful, but like magnify it, that would be a better pantomime. But no,
so
I tap.
I mean, I can zoom in more. Does that help?
Yes.
See some of yeah. Okay. So I will zoom out and I'll zoom in again just to show you kind of what we're looking at. But this, just to give more of a bird's eye view. So what you see here is our OpsCruise landing page. So you know what? Just to set the tone for what we're even talking about, because you did mention APM at the beginning of the call, but I want to go a little bit further than that and say we're not just APM, right? And I think really the industry as a whole is starting to move away from just calling themselves APM, because I think APM is just a snippet of really what the larger observability space has turned into, right? So very, very key here. The reason I bring that up is because this view that you're seeing here, what it is, this demo happens to be inside of AWS. This is a mostly Kubernetes cluster. You'll see some things like virtual machine processes scattered throughout, maybe some PaaS services. You'll see an RDS instance here. You'll see a load balancer here as well. So you'll see some of those, but the most of this is Kubernetes. And the reason what I'm trying to get at is that, in fact, this view is built without actual code instrumentation. So there's that whole industry of moving from just APM or just standard like node monitoring or VM monitoring, or just a specific entity's metrics and that's it, or a specific entity's logs and that's it. The whole industry is kind of moving to somewhere a little bit deeper. And so specifically when it comes to APM, we love APM, we love code tracing, we support code tracing. But funny enough, this view is built without any code tracing. And that's some of the marvels of the new ways that open source and just, the new observability paradigms have really allowed us to be flexible. So I'll show you guys what our code tracing looks like in a sec, but really, really cool. This is done all leveraging eBPF. This is all leveraging contract as well. And so what you're seeing is basically a real-time view of these services interacting with each other. And I think, Hilliary, correct me if I'm wrong, but this is what the map you were referring to earlier, right?
Yeah, this is the thing. This is the thing that I was like, I love this.
Yeah. So this is one of our biggest, features that customers love. And the really cool thing about this, as I mentioned, you deploy OpsCruise. So OpsCruise is really what we're doing is we're leveraging the underlying open source tools. So actually, I'll switch to my architecture really quick, and I'll come back to this and we can talk in more detail about it. But here on the left side, you have your components that are being collected. Could be PaaS services, could be Kubernetes data, could be messaging layers, whether they're PaaS or on-prem, virtual machines, containers, etc. Right. So you grab data from there. The type of data, again, metrics, events, traces, logs, configuration, network flows. But the way we grab it is really leveraging the open source components, things that are now becoming pretty standard inside of modern application environments. So things like Loki for logs, Prometheus for metrics, Jaeger and Tempo for traces. We support the OpenTelemetry standard. We take data from cloud. So this is really where we're bringing all this data. Excuse me. So that includes the eBPF component that allows us to do discovery of all these entities. And yeah, so this is one of the really cool things. Now, once you deploy that stack, which by the way, if you don't have it, it's okay. We can deploy in about 3 or 4 minutes, just a couple of Helm commands, you're up and running. And this whole thing, the cool part is that this whole thing gets discovered in about a minute or two after you deploy. You have this full map. It doesn't matter what language you're using. You don't have to install any specific language agents. You don't have to do anything special because of the underlying way that we can now collect data. This is self discovering and constantly updating as soon as you add new workloads. So the other thing I want to call out is, once you're in here, the really cool thing is that not only are we showing you, if you look underneath the covers, what we're doing is that we're providing we're providing topology, right? Your application topology, now dependencies, and you can know the relationships of what's talking to what. If I zoom in a little bit more, as Hilliary asked me to earlier, you can see that there's arrows and kind of graphical indicators in which direction traffic is flowing. So you can see what's calling where. And in fact, not only are we doing like network discovery, of services talking to each other, but what you're seeing here is a mix of endpoint to endpoint connections and also configuration data, metrics, etc. And let me show you what I mean by that. So, by the way, I'm going to turn off there's some components like the components that send the OpenTelemetry data or the open source data out into OpsCruise, and some of these are running inside of this cluster. So I'm just going to turn those off. And so this is actually really handy for when there are teams that only want to see their specific namespaces or specific applications. You can filter here by labels. You can filter by specific pods. I'm just going to turn off the OpsCruise stuff just so I can tell you what we're looking at. OpsCruise and collectors. So we have a couple of apps in here, and the one that most of you will probably be familiar with is the Google Microservices Boutique, right? So we're running the online boutique sample application here, and so that's what you'll see if you're used to that application and you've seen it or run it inside of your environments before. These service names will be familiar: shipping service, cart service, front end, etc. And again, all this was auto discovered. But yeah, I turned off some of the stuff just because this is what's important to me right now. And in fact, I can save, different views. Like if I want to see everything, I can just apply my all services view versus if I'm only interested in, like I mentioned earlier, my online boutique. Well, I can apply those filters and I'm only seeing, those specific services, and I can, tweak and share, etc. But I'm just going to clear everything back out, just turn off OpsCruise and yeah. So all this data is being collected. And what I mentioned is that we're also grabbing the telemetry data and it's being represented here. So if I click on any one of these entities, right, I just double clicked on a pod. I'll zoom in a bit. I just double clicked on a pod. And if I click on that pod again, I can, there's just the container that's also sitting inside of that pod is visible there. But I click on the pod itself and I can see the checkout service, right? So this is that checkout service pod. I'm in that context. I'm looking at things like configuration data, right? So the labels that are attached to this pod, which are actually something we can use to group, and I'll show you that in a sec. Labels attached to it, configuration data, things like the host name that this pod is running on, whether it's an ingress pod or not, the namespace, the IP address of the pod, the host's IP address, when it was created. So it looks like today at 3:30 in the morning, or actually yesterday at 3:30 in the morning. And on top of that, really important to context, especially for like OpenShift and Kubernetes clusters, going in and looking at what's running, you have a couple of different options. If you have good GitOps practices, what you can do is you can look at your repository and make sure that you can see what's the running config for a specific entity. But that means that when you are in your observability platform and you're trying to troubleshoot, then you would have to go inside your other tool, inside your repository, and check the running config. Your other option is going into the command line and running OC, get pods, or kubectl get pods, and looking for the proper output, etc. What we've done is we've brought all this data into context, and so now you can just, when you're looking at a pod, and say, okay, I see that this checkout service is talking to product catalog service. What's my config on there? I can just click on detailed view, and now I'm looking at the full-on YAML manifest for that particular entity. Right. So I can, instead of having to go to command line or even go to my repo, which is awesome, using GitOps is ideal. But having to go back into a repo, into a separate place, is not ideal when you're trying to, especially like you have a production outage and you need to make sure that your port is exposed, that your container is exposed on the appropriate port. You don't want to go back into your repo, log in, and then just look for, we've got it all in context immediately.
Yeah, that's one of those right tool at the right time for the right job type of things.
Exactly. Yeah, no, exactly. You don't want to be. That's a lot of the the philosophy that we kind of are hoping to bring to the industry. It's context. Context is king, because if you need to look for information, right? One day you might be tired. One day you might have only slept a couple of hours, and you have to remember the name of something, and then you go to your other tool. By the time you log in, especially now with like multi-factor authentication, by the time you log into your other screen, you're like, what was the name of that service? And then you're going back and back, and it's just it's juggling. It's a lot of swivel chair operations. It's painful sometimes. So yeah, you'll see that a lot of what we do is bring context. In that vein, you can see on the right side, in the context of this pod, we're bringing in the telemetry data, right? So things like metrics. If I want to look at the metrics for this particular service, I just click on the metrics link, and immediately, and anything that's zeroed out will just collapse. I could expand this if I wanted to, but it's just zeroed out. So memory utilization, CPU utilization, file system reads and writes, network reads and writes, etc. All this data is immediately accessible with a single click. And this is important, right? So I'm kind of laying the foundation of some of our more advanced features, like automated anomaly detection, automated root cause analysis. But having all this data is kind of the foundation for what we're going to show you in the context of an anomaly. All right. So I'll come back to this, but it's important to know that we have access to all this data. Any events, right? Any events last 24 hours, maybe I'll go back to the last couple of days. So as I mentioned earlier, you saw that the pod was created at 3:31 a.m. This is how we discover that. We grab all the events that are related to an entity, and we see that it was deployed yesterday at 3:31 a.m. And then logs, same thing. If I want to look at logs for this particular entity, I don't need to write a complex query. I don't need to copy the name from my command line and then look at logs for looking at yesterday, etc. I just click logs and boom, I'm there. All right, I can see, I can search, or if I need to search for anything specific. And there's some pretty cool things, like we just released some interesting functionality around being able to create alerting on specific logs. So that's there. You can write these custom queries to alert you on it, but context is brought to you automatically even without it. One of the other things that's really cool is, this map is cool, and it's kind of easy. But once it gets bigger, we have customers with thousands and thousands and thousands of pods. The visualization does get a little bit harder to parse, as you have 50 services you're talking to. So one of the really cool things that we've done is you can see this whole network flow, this service to service flow, but in a tabular view. I just click connections, and now I can see the source. I can see that checkout service is talking to a few different containers on this IP address. I can see it talking to the core DNS service. I can see it talking to Jaeger because it is outputting some traces, which I'm going to show. But yeah, this is one of my favorite features to understand the entire list of what it's talking to across different ports.
Yeah, probably unpopular opinion. I prefer visualizations like that over like shiny UIs with all the and I know I'm in the minority here, right? Like when you in this I want things in list form always and forever at every juncture. I don't care if it's like Jira and I'm managing my work day to day, or if it's something like this. I am the worst. People ask me what I want in a UI, and I'm like, I want a list. Actually, if you could just give me a list, that's great. That's all I want from a UI ever. I think every UI researcher who's ever interviewed me has left the room shaking their head and wondering what just happened.
No, I think you have a very, very valid point, right? So I like our visualization, and in fact, I really like that I can go into dark mode. The joke I always make, which is not really a joke, is that we all, especially now with people being remote, etc. Sometimes I'm in bed and I'm working, right? I need to check something, and I need to maybe look at an environment. I really like that we can go into dark mode because that way my wife doesn't kick me out of bed or make me turn down all the brightness on my on my screen. But so this is nice that we can go into night mode. But
Yeah.
what I was going to mention is, yeah, these visualizations are cool. Looking at night mode with the blue on black is pretty cool. But when you need to ingest a lot of data, quickly and really understand what's what, it's we can discover the ports that it's talking over by hovering over. Like if I zoom in here and if I see this edge here, I can click on it and I can see the port that it's talking over, and you can even see like level 4 traffic. But being able to just see in sorry, let me zoom out a bit. Being able to just see in list form without having to go, okay, what's here? Okay, what's here? Okay, what's here? It's easily digestible. Consume, find what you're looking for on the spot. So I agree with you. It's kind of going back to what you said, right tool for the right job. So yeah. So
Um, I
go ahead.
like dark mode. I don't think you guys showed me dark mode the last time we spoke. Actually, one, I find that visually easier to parse, which
Agreed.
I think most people do. It's kind of where that dark mode isn't the default across a lot of systems.
Yeah.
And then yeah, that part about being somewhere where bright light would be very disturbing to the people around you.
Yeah.
So I have young children, and actually one of my sons is homesick from school today, but yesterday, because he was sick, he was having trouble falling asleep. So I'm sitting there like holding the child so he'll go to sleep, and like also trying to finish up something on my on my
Yeah.
phone for work that I didn't get to earlier in the day. So
Yeah.
I think that was that. Yeah, I super relatable. I think we all feel it. We do have a question from the audience. Um, so Johnny asks, can you export that table data that you were just showing?
So a couple of things. Not currently. We've gotten two different requests. One really old school, and one obviously more new school. One is we've gotten a request to be able to export this data to Excel, and it's interesting that some people still use that format. I think it's painful, but there's different processes, different ways of ingesting data at different companies. And you're right, like security teams, a lot of security tools take CSV files or Excel files and consume those. The other request that we've gotten is for an API. So I know that the API is in active development for being able to export this type of data. Just run a query against OpsCruise and say, from this time to this time, what were all the entities that were interfacing with my checkout service, right? Or, so that's something that's being worked on. It's not in the product yet, but it is absolutely a roadmap item. And if it's something you're quite interested in, if you say, hey, the OpsCruise is really cool, and I'd like this particular functionality because I can export to security or I can export to whatever, definitely please reach out and we can talk and see what your specific needs are and put it in there.
Okay, I think we can let you move on to the next topic now. We geeked out
Sound
enough on this. Show us something else that's cool.
Yeah, absolutely. Okay. So, you know what? I do want to show one cool thing though. When you have all this, I just cleared all my filters and now I just have everything in here. Well, I mentioned we have some grouping functionality that can be used on auto discovered labels or namespaces. So this is like really handy, like when you have a bunch of, especially like one of the things that I see in, OpenShift is beefy, right? There's a lot of different components that are running inside of there. This is not OpenShift. I wish I had an OpenShift environment to show you, but it's one of the things we can do is group, right? So we'll find in like customer environments when they're running like big, either thousands and thousands of containers, or they're running something like OpenShift and they want to see all the OpenShift components separated. You can group by things like namespace. So I can just turn on this grouping function, just say group by all namespaces. And now what this is going to do is this is going to show me the individual workloads that are inside of these namespaces, right? So online boutique, collectors, etc. And I can just kind of play with the format here. The other thing you can do is if I go into online boutique, based on the discovered labels, right? And again, you guys don't have to do any configuration or all this is just out of the box functionality. So we have a label discovered called app. So I can just say label app, and it just show me all of them. And now instead of grouping by namespace, we're grouping by label, right? So there's these apps called shipping service, front end checkout service. You see Promptail in here, Logi. So that's another kind of pretty cool thing that you can do to see what are all my apps that are running inside of here. So that's
Yep.
that's the last thing I'll show.
Speaking of OpenShift, so actually when we last spoke, you actually did show me this on OpenShift.
Yes.
And so now I'm going to ask you the thing that I was going to avoid asking you, but we're going to ask it anyway. Operators.
Yes.
Have you all built in support for operators and their operands yet?
So no, that's still in development. So one of the things that I think we showed you last time is we have auto detection of, any, at the end of the day, operators are just pods and containers that are running inside of the cluster, right? So we do pick up that data, we do see them, and just like we provide visibility into the logs and metrics, et cetera, all those pieces are automatically picked up and brought in. So the operator functionality is visible and trackable through logs, et cetera. Now, there are more specific pieces of functionality inside of different operators that we are working on bringing into the product, but that's not fully fledged out yet, just to be clear on that.
I mean, we only just talked about it, in the summer?
Something like that,
so, that makes sense. But yeah, I think when we talk about OpenShift, there's OpenShift as you've seen it, which is where you deploy it yourself. And then there's OpenShift Dedicated, right? And OpenShift Dedicated it's managed OpenShift. So you've got SRE behind it. It's, there's a few different flavors of that. There's the classic OSD, which is runs on AWS or runs in Google Cloud. There's ROSA, which is a way more integrated version of OpenShift Dedicated with the AWS experience. And then there's, we call it Arrow, which is Azure Red Hat OpenShift. So it's our OpenShift Microsoft joint offering. And if you think OpenShift is beefy, managed OpenShift is that again, because all of the things that make it managed and make it nice and provide that experience are also shipping in it. So OpenShift is OpenShift. At the end of the day, there's not differences in opinions really between the two of them, but it is one of those things where there are a lot of things to OpenShift that make it OpenShift, right? I think we often, at least the engineers often call OpenShift opinionated, and those opinions are often represented as you could see them as group workloads on a diagram like this.
Right. Absolutely.
For more information on the opinions of OpenShift, I highly recommend watching Ask an OpenShift Admin. And just throw Johnny and Andrew under the bus and let them take all of your questions.
So I will say that, we've seen that. In fact, some of our customers are using, Arrow. Some of our customers are using OpenShift on-prem. And so, full support is there for all those. Basically, any downstream Kubernetes variant is absolutely supported in our platform. But there's ongoing work on getting deeper into these operators. I'll say that without going into too much detail, because at that point I have to bring in my platform architect to talk a little bit more about that. But yeah, so the answer is that it is also being worked on.
Wonderful. Right. Love it. Let's go on.
Cool. All right. So we have a couple of other kind of cool views that we have in here, and then I'll kind of show you traces and anomalies towards a little bit more towards the end. But here's a kind of another cool view, and again, the dark mode is supported throughout the UI. In this case, we are running a 5-node cluster, and you can see all the individual nodes, these large boxes. So now it's more of a physical layout. So before it was more of a topological, what service is talking to what service. Now it is what service is running inside of where, right? So I can see all these different pods and containers running inside of these individual nodes.
Sorry, I'm going to interrupt you. Can you make
go ahead.
Can you make it bigger?
Oh, sorry. Yeah, you were cutting out. Let's see.
I'm blind. I can't see it. There we go.
Does this help? All right.
Yes. I'm going to say that's good enough. We'll let the audience chime in if they need it any bigger.
Gotcha. So, so what this is more of a physical layout, and I can see some important metrics, things like CPU and memory utilization at a high level for each individual node, the node names, some instant details, IP address, status of the node, and then I can see all the workloads running inside of it. So again, that quick view that we saw earlier, is still available, basically throughout the entire platform. I can click on this Nginx pod, and back inside that Nginx pod, I'm now inside of that quick view, more in the application context, can drill down into logs, etc. But a couple of cool things on here. So if I want to see the configuration of this specific node, again, no need to log it into your cloud provider of choice or your virtualization platform of choice. No need to go into kubectl get nodes -o YAML or whatever and take a look at your nodes, or even log into a separate UI. You can just click on the config piece, and now we're giving you the configuration for this particular node. All the labels attached to this node, whether you're using those labels for like affinities or whatever. They're all available right here. You can see the IP addresses, the runtime version of the container platform, the IP address for any network overlays, kubelet versions, etc. Right, storage attached to it. All this is visible in context. You can see the same thing, that the full-on YAML file that's configuring the node and powering that. And also, one really cool thing that I like is, I should actually, before that, I'll call it metrics too, what you would expect, right? Disk utilization, IO time, network utilization, CPU, etc. All those metrics that you would expect to see there are available in context. But now, kind of a really cool view is our balancing view. So our node balancing view, what it does is that it shows you at a CPU, memory, and disk level what your consumption of resources is, right? So here's an example that is actually kind of interesting. So I'll just look at the CPU side, but you can look at memory, you can look at disk. So for example, here in this online boutique namespace, we have the load generator, right? And this load generator inside this container is main. But you have a request set to 20 millicores with a limit of 500 millicores, right? So that's kind of interesting, because if I look at the value of utilization, it's pretty low, right? For the current is 9 millicores, one day average is 9 millicores, and the one day max is at 14 millicores. This might be an opportunity to drop your limit to maybe something lower, so you can make sure to schedule more workloads on this particular node, right? Or if I sort by a couple of others, let's see. Let me find something that's maybe a little bit even more dramatic. So here, the payment server, right? Now I'm going to look at memory for the payment server. So if I look at memory, I see that the request and limit are kind of pegged right at 4 gigs. But I see that it's pretty much static, right? 940 megs on average. So we want to have our clusters not packed to the brim, but moderately to semi-densely packed. This is probably an optimization opportunity to make sure that we're squeezing the most that we can out of our clusters. So this is just kind of one view. Hey, we can probably drop this request down and limit down maybe to a couple of gigs, cut this utilization in half, and now we have some work for an additional workload on this node. So,
so, and you might get there. So feel free to tell me to just wait patiently. But I'm curious as to when we're looking at these things, do you have like a fleet viewer? So like, let's say I have 17 clusters that I'm looking at. Do you have some sort of fleet-wide perspective on some of these same things?
That's a great question. The answer is currently, unfortunately, well, it's not no. We have a V1 release that I actually don't have in here, of a cluster of an environment-wide view where you can see multiple clusters, anomalies across clusters. I actually should have brought that environment up to show you. Unfortunately, I don't have it up right now. But yes, we've just very recently released that view. It is something that we've been actively working on. That is kind of a big piece of our roadmap. A lot of our customers just flat out have lots of environments, right? Lots and lots and lots of clusters. Some of them have two. Some of them have two enormous, clusters. But then there are, the opposite kind of end of that, where there are, 50, 100, 500 clusters, but that are small. So that view is in active development. There's a V1. If you guys are interested in that, I can follow up with you guys and show you some screenshots, etc., of an environment running that view, but not active in here.
Yeah, I mean that's fine. It was and yeah, I mean I think we see obviously there's a Venn diagram of our customers, and there's like you said there's people that you have in your customer base who are OpenShift users, and yeah, we see the exact same thing. Some of our users have one like 55 node cluster, and some of our users have like 10 5 node clusters, right? Like and anything to either end of that spectrum, in between, beyond, who knows what people are doing. It's every single person, every single company has something else that they're receiving in terms of value from the platform. So
Right.
yeah, it's one of those things. And I think when you think about a fleet, and you think about like fleet management and anomaly detection, right? I know one thing we hit in the observability in our space is, well, some of these clusters are dev clusters, right? These are development environments. And so when we're looking at them from a managed perspective, what might appear like ordinarily would be very strange behavior is perfect behavior in that type of a context. So
Right.
I know that's one of the most interesting paradigms we've had to deal with from the reliability engineering perspective on
Yeah.
that platform is, okay, well, yeah, we've got to keep our stuff up and running and so forth, but also these are development clusters. So sometimes we're going to see some stuff that's kind of weird.
Yeah.
Um, and I'm not sure what from like your side perspective on the customer interactions on that type of thing looks like in terms of how your system interacts with those types of environments. But I know on our side, it's resulted in some very enlightening conversations with our customers where we really get to learn about just very cool things that people are doing.
Yeah. Absolutely. I mean, it's an interesting it's an interesting scenario to run into, right? So yeah, you're right. Especially with Kubernetes and basically any like modern platform where you're doing a lot of GitOps, a lot of constant releases. You see interesting behavior or behavior that in production would be you know level one priority, call the entire company and get them on the line kind of scenario, versus in a dev environment nobody even cares, right? And it's just that kind of paradigm. So one of the things we have a couple of interesting features that hook into that. I mean, uh, we have machine learning anomaly detection, right? So when your behavior is out of whack, right? I'll kind of skip into the alerts here. I'll find something that is ML based. So for example, here we have some network metrics that are not normal in one of our containers, right? So in this case, it looks like we have a request count spike, right, which is abnormal apparently for this particular container. And not only we're not looking at just one metric, right? Our machine learning is looking at a bunch of different metrics per entity, right? In this case, it happens to be a container, so you're going to see more infrastructure metrics, things like request counts, memory utilization, file system utilization, network utilization, bytes in, bytes out, request rates, error rates, all those kinds of things are taken into account together, right? And I'm kind of sidetracking. I'm going to come back to that question, but yeah, all these things are taken into account together. And so when these metrics behave anomalously, even if they're not pegged, right, where you don't have to wait until you're at 99% of memory or 95% of memory to trigger an alert. If things are abnormal, if you're having 50 requests and you're typically, at 50 requests per second, you're at maybe 20 megs, but now you're at 50, 55 requests per second, and you're at 5 gigs of memory. You're 100 times over, whatever that might be. Plus, your file system is going crazy when it usually doesn't for that level of load. We detect those metrics, how they interplay with each other, and then we'll fire an anomaly. But my point of that was to say that we have, like, for those other environments, for those lower environments where you have like erratic behavior, you're maybe going to send a sudden surge of load, et cetera, and you don't want it to be detected an anomaly. We have what we call lightweight binary feedback on whether this is really a problem or not, and it's actually really valid for production too. But we see it used often in dev. So I have a machine learning alert that we were just looking at, and we're going to dig into some of the more cool pieces of that if we have time. But I can just say, hey, you know what? I hit this minus sign. This is not an anomaly. This is normal expected behavior. And that helps kind of tweak the sensitivity of the machine learning to those kinds of scenarios inside of those lower environments, like you said, to help avoid, excessive noise for what is perfectly normal behavior in that type of environment.
Yeah, I think so. In one of the previous streams, one of the things, actually, ML around alerting and ops and so forth had actually come up as a question. And it was one of the things that we talked about there. And I'm sure you can fact check me on my hot take here. I think in order for ML to be truly effective, you need to actually first baseline understand the behavior of your workloads in your environment because it requires the training and the tuning. So
Yeah.
I'd love to get your hot take on my hot take.
No, that's absolutely true. I mean, and what's interesting is, you're right on point, and then going even further. you can't just learn once and set it and forget it, right? The reality is that you need to be constantly learning and learning and learning. You know, your ML needs to constantly learn and constantly updating those models, because those models can quickly be out of date, right? So, for example, OpsCruise by default, we learn like every 24 hours. We'll retrain our ML. That can be shortened. Like if your time cycle for relearning needs to be at 5 hours or whatever, you know, that can be shortened. But by default, every 24 hours. So we're not, and also we're not moving that model over. Let's say you have you have some sort of uh, you know, you have an Apache application, and we are, you know, learning on that, and then we're propagating that same model to all of your other Apache instances in the cluster. That's not what we do. So each application, each deployment has its own model that's learned. So we have a model template. We know what metrics to look at. Like I showed you, you know, you'll have a different set of metrics, of course, for like a Redis instance than you'll have for a container, than you'll have for a node, than you'll have for, you know, a database. So uh, those those models are built to look at each instance of your microservice and learn from there, and then constantly be learning. So your hot take is actually a good hot take, right? It's not necessarily something to be argued. It's absolutely on point. You know,
This reminds me, there's something I've said before. I'll said it before. I'll say it again. I'll probably say it until the day I retire. The software development lifecycle applies everywhere, across the board. Apply it to everything, right? Apply it to your GitOps. Apply it to your ML. Apply it to your documentation. Apply it to your operating procedures. Wherever you are doing a thing, the point of the software development lifecycle, of course, I think I'm speaking to the choir here, right? Is that you take what happened after you did the design and implement and all that other stuff, and you put that back into design again, and you take that information and you redesign based off of what you've learned. So that last little part of the feedback loop, right? Just everywhere, across the board, every aspect. I apply the software development lifecycle to the way I wash my dishes, right? Like anywhere that you can do it. Observe, take your observations, put them back into your design phase. And one of these days, I will be better at spatial reasoning and be able to effectively load my dishwasher, as well as the person who helps me with my housekeeping does. Today's not that day. She's still better at it than I am, but like, I get better every time. I grew up with a dishwasher. I should be better at this. I'm just not. She's like, her Tetris game is just the best I've ever seen, which is a huge digression. But
yeah, don't get me started on dishwashers.
We're just straight up like silly over here right now. I'll let you get back to it.
No, but yeah, dishwashers are a sensitive topic in my household. I'm like, why does my wife wash the dishes by hand if the dishwasher is there? And so don't get me started on that track.
Oh my gosh, I have. There are so many reasons why that is. We could have it like follow me on Twitter for my thoughts on dishwashers. I will post them after.
Gotcha. All right. So okay. So let's kind of come back into here. So one thing before I fully show off the anomalies, and you know what, I'll show a couple of anomalies as an interesting piece. So like our anomaly detection is based on, as you saw earlier, we have machine learning anomalies. We have rule based anomalies. Just we play both in the app space and the infrastructure space. So things like, let's say you're focused more right now on the Kubernetes side, right? You have a deployment. The ad service deployment is broken. There's no available replicas for more than 120 seconds. Maybe I'll switch back to light mode just to kind of wake us up again. So I have a deployment here and it's failing. I don't have enough replicas. I can click on it, and now I'm seeing, hey, there's you have less replicas than what you intend to. You want one, you have zero. A bunch of important information about the namespace that it's part of. The entity that we're looking at, which is the ad service. I can click on it and go back into this config snapshot for the AD service. Again, this is at the deployment level. I can look at the configs in the context of the anomaly, right? So this is the config for that deployment itself. I can look at metrics. I have what we call time travel, but I'll focus on just kind of the shortcut of this. If I click on analyze, this is now our root cause analysis engine kind of taking place, right? We identified that there was an issue with the deployment. And now we bring up this Ishikawa diagram, or what we just call our Fishbone Rca. And so this is very contextual to the type of anomaly that is present, right? And I'll show you in a second what it looks like for maybe like a machine learning anomaly that's metric based versus this configuration anomaly. you'll see different categories: pod scheduling, node failures, startup failures, runtime failures. So you see there's some issues with scaling up, scaling down. There's some back off restarts. But pretty interesting here is that we have an invalid image tag. All right. So if I click on here, I'm bringing up an invalid image tag. I'm trying to get this add service name. I'm looking at this image tag. If I'm even, if I want to be a little bit more adventurous, I can actually, go to this repository, and I'm opening up that repository, and I can see that I am trying to pull a tag called v040_error, and there is no tag in that repository for that image called v040error, right? So there's clearly why, this is bringing me at root cause as to why I can't pull the image, why my deployment is broken. I have a bad image tag. So we take different steps in our causal engine to really walk through all these different pieces and understand, all right, is it you? Am I out of memory and I can't? So if you are if you don't have enough memory to schedule a pod, right, you might get one of these triggered. Insufficient CPM would say, hey, you want to assign 500 megs of memory, but you're completely out of memory on all your nodes, so we can't start up. So those are the kind of things that we help identify. The other thing, let me just go back into my alerts here. There's other types. So as we saw, the machine learning alert was triggered. So if I open up this machine learning again, and now actually go to the Analyze tab, you'll notice that the categories have changed, right? So I have like memory and CPU, and I can actually see why RML fired, right? So this demand side is incoming request. On the incoming side, everything is good. But on the outgoing requests, right, I have a spike, a 211% spike on my outgoing requests. I have some increase in file system utilization, 204%. And so these are all things that our machine learning has detected as abnormal. One of the cool things that we do is, instead of having you build all these custom dashboards, which we do have the capability around, but we really try to shy away from that because, as mentioned earlier, context is king. So we try to bring the context to you and feed you what's going on. So instead of going to a different dashboard or building a drill down, all right, when I'm in here, drill me down into this dashboard, we're automatically dashboarding these important things for you, right? Again, it's not losing the context. I can see my response time during that time frame of the anomaly. I can see my file system reads, how they're going up and down. I can see the CPU utilization. I can see all this data basically in the context of the anomaly. And if I want to go even further in this detect tab, I have a bunch of data that I can access. If I want to see logs, for example, I can click on logs, but it's not logging because it's not even starting up. So that's, but when you have an issue in your application, you can drill down into the logs. You can drill down into the configuration, as I showed. Also drill deeper into metrics, right? If I click on metrics, now I'm going to look at the metrics, and you can see during these time frames of the anomaly, you'll see these red bars, what was happening on this particular instance. Now, there's some other pretty interesting things that I can show, but I do want to show you something that we recently came out with, and before we run out of time, and one of those things is the tracing capability that was your very first question that you asked about APM, right? So we recently introduced APM into our platform, and we do something that's really, really cool. Before showing this, actually, I have a slide to really explain the kind of differences between what you saw earlier in that automatic network discovery map and what the tracing piece is. So that app map, which is really, really cool, all right, has its shortcomings, mainly that you can't look at the code level, right? That's just, for code level, you require code level instrumentation, which is a distributed tracing component, the open telemetry libraries, Jaeger, Tempo, etc. So this is what you saw earlier, that map. It's service A talks to service B, talks to service C, talks to service D. If you're talking in HTTP, we can actually see the URLs that are being called between each services and performance, and we have a screen for that. But then the other kind of side of the spectrum is traces, right? So once you enable traces on your application, you're going to see all these individual requests. Again, your basically your business flows traversing through the system. But here's what's happening. So for most tracing platforms, and again, this was my bread and butter for many years, so I can tell you that I dealt with this day in, day out. A trace gets named basically on its entry point. So if you have maybe like a search, right? And so let's say you have a search transaction flow, right? even if it takes branching paths, which you would see here, that it's going to a different place, since they all start at that search, they're all just going to be aggregated as a search. So when you're looking inside of your system, you're just going to see a single, transaction flow called search. And the problem is that you're actually taking different paths, which means this could likely technically be categorized as a different platform. Here you're hitting, operation B1 versus here B2. That could completely change the response time. You might be hitting, basically a different microservice or a different function. It doesn't matter. But because of the way tracing is designed, they'll all get aggregated into one. So there are ways where there are the platforms where you can, typically I would have to, when I was doing delivery, sit with the developer, find their, talk to them and say, well, what can we split out these transactions on? Because my search, this one is mobile, but this one is desktop. So how do I identify between mobile and desktop searches? Well, we have a request parameter. Why don't you split on the request parameter? Or we have some method argument that gets called. Why don't you split on that? So it's involved. It's possible, but it's involved. So the cool thing that we've done is, without having to involve developers, without having to do much of anything, once you've got traces being fed into the platform, we will automatically identify the different service operation pairs that are being traversed. So even though the search starts here at the same place, we'll identify that, hey, this is hitting a different operation. This is technically a different transaction. So what we will do is we will automatically split them up for you. And instead of seeing aggregated metrics for just a single transaction, you will see the metrics for the transaction type 1, what we call a trace path, and then trace path 2. All right. And what that looks like in practice is this. I'm going to go into our trace paths view here. And so I actually renamed these. So I'm actually, I'll show you that. I'll just reset the name here and reset the name here. So you can see, right, if I see this receive cart, we actually have, it looks like 3 of them. But if you notice on the trace path, what we've done is we've identified that this is hitting front end 7 times and 1 time to the product catalog service, while this is hitting the receive cart 3 times and only 1 time to the product catalog service. So I can click on it and see a view. Right here, my 7 calls, 1, 2, 3, 4, 5, 6, 7. And then this 1 call versus this other one, right? If I go back to all trace paths, I didn't take the reset. In any case, this other one that was only 3, right? And I see that it's only making these 3 calls. So those are separate transactions. Most other platforms would aggregate them and you'll just have a single receive cart. But what I've done is I broke them up. I'm not sure why the reset didn't stay, but I've broken them up. So I know that one of these is iOS and one of these is desktop. Even though they both start at the same place, you can see that there's different performance, right? This one is 3.94 milliseconds, while this one is at over 28 milliseconds. So performance profiles are different. The request counts are different. But now you're not getting aggregated data, because if let's say my cutoff for good performance is 25 milliseconds. Well, if you merge these together, right, assuming that it's 1 call and 1 call, if you merge these together and then take the average, you're at 28 plus 1, you're at about 31 milliseconds, average them out, and you're at 15 milliseconds. And you'll say, oh yeah, all my transactions are well within range. But if you actually break them out, you'll see that, yeah, your desktop searches are fine, but these other searches down here are above what your accepted SLO is. So what we're doing is that we're helping avoid false negatives on different traces. And I know I'm practically out of time. There's a bunch of other stuff that we could show. We have automatic anomaly detection on different trace paths. You can go back in time and look at your configuration, and we have a bunch of different root cause analysis pieces, but I'll stop there.
Awesome. Thank you so much. I was recently having a conversation. Like, why is Hilliary so passionate about this, right? I was recently actually having a conversation, and the person said to me, like, from an SRE perspective, what are just like some chores that we should be doing on our cluster? And I was like, oh man, like that. I told them, I said, there's an entire conversation that you and I need to have about observability, because there's not, routine maintenance and so forth, right? That's your sysadmins, right? More or less, most of the time, that's your sysadmins. They're going to handle that. But like, what are the things that an SRE does, right? We should be acting on this data that we see here and applying that back into hardening the systems, tuning the systems, actioning on this data in some way that makes services, platforms, workloads, applications, whatever it might be that you're interacting with on whatever degree, better, right?
Absolutely.
And so that's why the timing on this is like, we'd already had this scheduled and I had that conversation. I was like, this is such an important topic. A lot of times, especially in a profession like SRE, where we do spend quite a bit of our most exciting work hours trying to figure out what's going wrong in production, like what's actually happening, what went wrong, what fell over. And that really is just like the smallest, not smallest, this is just a small part of the bigger holistic picture, which is if you can get the current state of your application or your service based off of the metrics and the data that you're pulling from it, then there are things that you can do to make it better. So we are coming down to end of time. I greatly appreciate you coming on here, showing this off, talking to people about it. We've put some links in the chat, actually for checking out more about OpsCruise. I think I saw that you all have a free forever tier, which was pretty darn cool. And it's displayed on the bottom of our screen right now, actually. And yeah, so there is a, you all have a presence on the Kubernetes Slack as well. We've linked to some of that in the chat. And yeah, so I hope, viewers here, go, hang out, interact, ask questions, tell them you heard about them from me, so I get brownies points. There's no kickbacks, just brownie points. And maybe we'll have you all back again someday to talk about additional stuffs and things.
Yeah, that would be awesome. Thank you very much for having me on, Hilliary. It was a lot of fun.
All right. So with that said, just a reminder that next time we are back, we will have Christian Hernandez again, which I'm super, super excited about. And we'll be discussing the Argo rollouts. And with that, Johnny, I'll ask you to roll us out. And remember, folks, choose your technical debt wisely. We'll see you in 2 weeks.